Hey guys, great to be back with y'all again today. We're going to be talking about problem solving today. And we're going to be talking about a wide variety of skills, really. We're going to be talking about 3.4 A and K and 3.5 A and B. And that's problem solving with all operations, basically what it is. And the I can statements is I can choose the correct operation to solve a word problem, and I can use the correct strategies to solve to problem solve. So we're going to look at some of the vocabulary. Since we're using all operations, that would be addition, subtraction, multiplication, and division. Those are the four operations we use in math. And we have for addition, we have add in are the two numbers we put together to get our sum, which is our answer. And minuend and subtrahend and difference. Difference is the answer to a subtraction problem. There's a community property of addition. That means I can switch the numbers around and still get the same sum. That's not a fact with subtraction, though. There's specific order. We always start with a larger number in third grade and take away a smaller number from that to get a whole number or a positive number. Multiplication vocabulary. You know, it's factor, those two numbers we put together in our multiplication to get our product. And there's a community property of multiplication, which means we can switch numbers around. 5 times 4 is also 20. And division vocabulary, dividend, divisor, quotient. Quotient's the answer to a division problem. And we cannot switch around. I cannot say that 5 divided by 40 equals 8. That would not be a true statement. So there's a specific order way we divide things, just like subtraction. They're very similar. Have a few videos we're going to watch about these skills. We'll watch one of Aaron's videos talking about how to solve problems using different operations and stuff. So let's go ahead and get ready for those videos.
And division problems. This is standard 3.4K in the great state of Texas, and we're using item number 37 of the 2016 released STAAR test. If you have not done so already, please go ahead and take a moment, pause the video, see if you can work this problem out on your own, and then unpause it. We will look at our answers together. So this standard has both 1 and 2-step problems, and this happens to be just a simple 1-step problem. So we have Miss LaSoya. She's got 72 index cards. She's going to arrange them into 6 equal stacks, and then how many index cards are going to be in each stack. So our only clue here is going to be this term equal stack. So whenever we're looking at equal groups or equal stacks, that means that we are going to use either multiplication or division. Because multiplication and division only work when you're dealing with the same size groups or equal groups. So we see equal groups. Also, each typically gives us a clue that we're looking at either multiplication or division. So we can go ahead and knock out a few of these answers because you've got 72 and 6. So if you're not sure what to do, you can add the two. 72 plus 6, that's going to make 78. And that's where this answer comes from. That doesn't make any sense. How can there be 78 cards in each stack when you only have a total of 72? Some students might want to subtract the 2. We can regroup here, and you can see we're going to get 66, which is our answer selection here. Once again, that doesn't make any sense. If you have 6 equal stacks of 66, it's going to be a heck of a lot more than 72. So both of these are incorrect. And so what we need to do is we're going to need to either multiply or divide. And we can just use logic here saying both of our answer choices, 12 and 9 that remain, are smaller. And so when we get smaller, we're going to be dividing. Dividing is what makes it smaller. Multiplication typically makes our answers bigger. And so let's see if we can draw a picture of this just to kind of represent what we're doing. And we'll look at a few different ways that we can solve it. So if I wanted to make a strip diagram, I could do like this. I can say, look, I've got 72 total, so that's my max. That's why that 78 doesn't work. It's larger than my total. And I'm going to do 6 groups here. So I cut it in half, then cut each half into thirds. I've got 6 groups. So those are my 6 equal groups, and how many can I put into each? So if I do know a multiplication fact, I can probably get that done. 6 times something makes 72. But I don't necessarily know my sixes all the way up to 72. So let's see what, let's just see what we can do with some division. So we could literally just take this graph that we have here, this strip diagram, and we could just take our 72 and we can just split them up. So we can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and just keep going until we run out. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Now I've got 6 sets of 5, that makes 30. If I do 30 plus another 30, that's going to give me 60. So I'm just going to use my brain here a little bit. I'm going to put another 5 into each of these just to save me some time. Now that I figured out that 6 sets of 5 make 30, 10 sets of 5 is going to make 60. So that's going to make sense. If I can get that up to 60, because I've got so far 10, 20, 30, 40, 50, 60. Now I can go a little bit slower. 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72. So there we go. It looks like I have got sets of 12. 6 sets of 12 would make 72, or my number sentence could be 72 divided into 6 equal groups. It's going to give you 12 in each group. So our answer is going to be A, 12, and 9 is just another option that's smaller, but I'm not sure how we're getting 9 from there. And so we can finish this problem here by looking at 72 divided by 6 equals 12. This is represented with a strip diagram, as is this, because multiplication and division are inverse operations, and you can represent them both with the same strip diagram.
Okay, we're going to look at this problem really quick, and it's 20 divided by 4, and what we're going to do as division as repeated subtraction. So just like multiplication can be repeated addition, division we can solve as a repeated subtraction problem the same way. And this might be a for instance when we want to do that. Say for instance, like if I had 20 pieces of candy and I want to put them in bags of 4, and I'm trying to figure out how many bags I can make. It might be a for instance when I might want to use repeated subtraction to solve it. So that means that groups each and total. So I'm trying to find out how many groups there are, but I know I'm going to put 4 in each group, and I have a total of 20. So this is what the problem would look like. So I would go ahead and take 20, and I would make a subtraction problem. I would subtract 4. And 20 from 4, I cannot take 4 from 0, so I'd have to regroup. And but I can take 4 from 10. 4 from 10 is 6. And then I just bring that 1 down, so that leaves 16. That's one group that I took away. Take 4 again away again. 4 from 16, 4 from 6 is 2. And just bring the 1 down. And now I have 12 left. That's 2 groups. Subtract 4 again. Okay, I cannot take 4 from 2, but I can take 4 from 12, which I already have 12 right there. So I can count up from 4 to 12. So that's 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 8. So 4 from 12 is 8. And that's a third group that I've taken away. Subtract 4 again. 4 from 8. 4 from 8 is 4. That's a fourth group that I took away. And 4 minus 4 is 0. And that's a fifth group I took away. So how we do it is we keep on subtracting until we get to 0. So you can see that I have 1, 2, 3, 4, 5 groups. So 20 divided by 4 equals 5. And I know that because 5 times 4 equals 22. Let's look at another problem here. Okay, we're going to look at this problem right here, 88 divided by 2, and we're going to talk about partial quotient. We typically won't use partial quotient a whole lot, but in a, for instance, like this, where I have a relatively large number and I'm dividing it by 2, it might be helpful in a certain circumstances. So in this circumstance, I will say that Mr. Shoemaker brought 88 balloons to school, and he wants to give each student 2 balloons. How many students could he give balloons to? So in that case, I have the groups again, have the each, and I have the total. And on this problem, I know what I'm trying to find out is groups. I don't know how many groups I can do. I don't know how many people I can give balloons to. I know that I'm going to give each person 2, and I know I have a total of 88 balloons. So typically when I'm trying to figure out how many groups there are, there's 2 main ways we do it in the 3rd grade. It's partitioning, and that would be, so if I drew all the balloons, I drew all 88 and I start putting them in groups of 2. That would be one way of doing it. Okay, but that'd take a long time. That's a lot of dots, and we kind of lend ourselves to possibly making mistakes. Next way I'd probably do it is maybe an array. So on my array I put, so there's 2 in each, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I'll wait until I got to 88. And that would take a long time, a lot of space to do too. So on a number like this, 88 divided by 2, and I'm trying to figure out how many groups there are, I think I'm going to try the partial quotient. We could do repeated subtraction, but that would be also a long problem too. 88 minus 2, and then keep on subtracting 2. It's going to be quite a few. Okay, so we're going to use a partial quotient method of doing it. And it's basically very similar to repeated subtraction. So I take my 88, and I am going to subtract until I get to 0, but I'm not going to subtract 2 every time. I'm going to use the power of multiplication to do it a little bit quicker. So I'm going to take some of my 2 facts that I know that make some bigger numbers. So a 2 fact that I know real well is 2 times 10. I'm going to write that over here. So 2 times 10. And I know 2 times 10 is 20. Okay, and I can get even bigger than that. So we remember when we multiplying 2-digit numbers, I could do 2 times 20. 2 times 20 is 2 times 2 is 4. And then I just place my 0 behind it. So 2 times 20 would be 40, or 20 plus 20 is 40. So I've got those 2 facts right there, and I'm going to use those facts to make this go a little bit quicker. So I'm going to take my bigger number, biggest number that I have right here, which is 40. I'm going to subtract that from 80. Okay, when I subtract 40 from 80, I get 48. So what I did is I just subtracted 20 groups of 2. That's 20 groups of 2. So it looks like I could probably subtract 40 again because I have 48. So subtract 40 again. And 40 from 48 would be 8. And that's another 20 groups. So I cannot subtract 40 again. I cannot subtract 20. So I could just start subtracting 2. So 8 minus 2 is 6. And that's one more group. 6 minus 2 is 4. That's another group. I can subtract 2 again. 4 minus 2 is 2. That's another group. And let's go down here a little bit more. Now on my last, 2 minus 2 is one more group. So now to figure out how many groups I'm going to have, I just need to add all those numbers up. I'm going to add 20 plus 20 plus 1, 2, 3, 4 plus 4. So 4 in the ones place and 4 in the tens place. So 88 divided by 2 would be 44. So we're going to scoot down just a little bit to give us a little bit more room to work, because we're doing 84 divided by 2, and we said we're going to use a partial quotient method to solve it. So that would be 84. And we're going to figure out how many groups of 2 there are. Okay, so we could go ahead and figure out 2 groups of 10 is 20. So if I took away 20 from 84, that would signify 10 groups. Okay, I can get even bigger than that. 2 times 20. I know 2 times 2 is 4. And then I put the 0 behind it to mark my place value. So 2 times 20 is 40. So if I took 40 away from 84, that would signify 20 groups. We go even bigger than that. Go 2 times 40. Okay, 2 times 4 is 8. And we put a 0 behind it to mark our place value. That is going to be 80. So if I subtracted 80 from 84, that would signify 40 groups. So we'll go ahead and start with that. We don't need to go any higher than that because our number is 84. So we'll go ahead and subtract 80 from 84, and that gives us 4. And that signified 40 groups. So we know it's going to take at least 40 days to sell those candy bars. Now we'll go ahead and take away one more group. That's one group. And 2 from 4 is 2. And I take away one more group. 2 minus 2, that's one group. That gets me to 0. So whenever we're doing the partial quotient or the repeated subtraction strategy for doing division, we always need to keep on taking away until we get to 0, because that means we made all the groups we could. So 40 plus 1 would be 42. So 74 divided by 2 would be 42. And that's going to signify 42 days. So it took 42 days to sell all the candy bars. Okay. Another way to think about that, whenever we divide by 2, really all we're doing is figuring out what half of something is. So we could have done the same thing. We could have done 84 divided by 2. And we say half of 4 is 2, and half of 8 is 4. And that works good because our number has 2 even numbers there, so that makes it really easy to figure out what half of something is. If it's an odd number, in the ones place, we could not divide it by 2. We figured that out when we was talking about our divisibility rules for 2. So that's another way to figure out what 84 divided by 2 is. So it's going to take 42 days to sell all those candy bars. Okay, guys, it's time to go and complete your independent practice. I'll have a PDF right below this that you can print out and work at it out on paper. But just make sure you go ahead and do the blue puzzle piece, or you submit it that way, the blue puzzle piece with today's date on there. And just take your time and do your best on it. If you have any questions, though, please email your teacher or send them a message in Schoology. We'll get back to you pretty quick, and best of luck to you.